Welcome to Faastr,
a feature engineering and model building platform that helps organizations accelerate machine learning and AI processes. The models can be built on cloud engines, and this in turn empowers organizations to quickly innovate and solve some of the most pressing problems. Today we are going to be building a predictive model that will help us understand the risk for a diabetic patient readmission. Let's start by logging onto the platform.
The platform offers 6 prediction classes.
Our use case is a binary classification problem, so we will be selecting classification. We will create a new project and let's label it as patient readmission. Now we will select a dataset for it.
Faastr supports multiple data sources,
such as Hadoop, Snowflake, AWS, etc. Today we will be using Snowflake. Once connected to Snowflake, you will notice that all the databases are visible. Our data is under demo and it is distributed under patient encounter and patient history. We can drill down into the table schema by expanding. Let's select patient encounter and patient history and create the data set. As we preview the data, we can see that a lot of the values on this dataset are categorical. Therefore, they need to be converted to numerical values. For this, we will perform feature engineering. Under feature engineering, we can engineer features for both the files individually.
Snowflake will be our feature engine.
Here we can select a host of different transformations. For example, race has nominal categories, and hence we can one-hot encode it. The same is true for gender.
A log of our most recent transformations appears here. Additionally, the platform allows us to aggregate features. Let us engineer a feature to give us an average number of emergencies per age group. Let's select age and aggregate by. We then select number of emergencies and mean. Let's submit the feature. As we have 2 data sets, patient encounter and patient history, we will choose columns to aggregate these data sets and then join them. The join column would be unique ID and the default inner join works for us. Once we submit, we can see below the recent merge changes. We are now done with transformations on patient history. We can click here to view the config log. Let's now save the features and transform data for patient history. We will now move on to patient encounter. This dataset is a record of all the patient visits over time. Let's label encode, medical specialty, and one-hot encode insulin and submit. Now let's look at how insulin could affect the number of procedures. We select aggregate and then aggregate by insulin, and the operation is mean. We save all features and transform the data. We can now see that the data is transformed. The individual and joint tables are displayed here. Let's go into the joint table and select model configuration. The target column is remitted. We will drop a few high cardinality columns, such as unique ID, diag, patient number, etc., and set the configuration. We can now see a detailed analysis of all columns in the dataset. The app allows us to view feature lineage. We can select the project and the specific datasets from this tab. As we zoom into the lineage map to view more clearly, we can see our original dataset at the parent node, the columns, the default feature set, and finally the project patient readmission. Feature lineage helps us see how a parent dataset is connected to our project. Each node has a drill down for getting a detailed view.
As a next step, we will build multiple models and deploy the best one. For that, we click on Experiments and Create Model. Here we have Random Forest, Logistic Regression, LightGBM, XGBoost, Teapot, and AutoML. AutoML is nothing but runs all the other models and gives the best performing one. We will use the first 4 and select the data set and create the model. The application notifies us as and when the models are created. You can see the notifications here. Now that all our models are ready, let's us take a look at the model accuracies. One can also see the ROC curves on the right-hand side. Let us choose XGBoost with an accuracy of approximately 70%. One can see the test, cross-validation, and the trained metrics on the dashboard. We can also an explanation for the model for each feature. Let us now deploy this model. All the models that we have deployed are under the Models tab. We can click on the link to access the model URL. Let's try it out. This is our response. So we have successfully created a model for patient readmission by just clicking a few buttons. Now let us see our deployed model in action. We have a patient in the age bracket of 50 to 60 and we can see the patient data including his number of lab procedures, medications, etc. So what does the model has to say about the patient's chances of readmission? As you can see, the model has predicted a low risk for this patient. The next patient is an African American and is in the age group of 50 to 60. He weighs a little more than the earlier patient and he's had more number of procedures and medications. So what does our model have to say about his chances of readmission? His prediction turns out to be medium risk. Lastly, let's us check on our third patient. She's a Caucasian in the 70 to 80 age group, weighing 180 pounds. She has had a high number of lab procedures and medications. The model predicts her to be at high risk patient for readmission. So there you have it.
Today, you've seen the feature engineering and model building capabilities of Faastr through a single use case.
We've looked at how features can be quickly engineered and how data models can be built to predict patient readmission risk.
You can use Faastr to drive operational efficiencies and deliver improved care.
Whenever you are ready for innovating, simply visit our site and book your time. We will jump on to help you. Thank you.